All right. So we'll just brush over what we did last time and the example I did about second order ODE that wasn't very satisfying to me. So what I would like to do is today just do two or three examples related to the homework, and if we can do more than that, that would be a bonus. But at least the homework problems we won't able to tell you how to go about them. Okay. So recording is on. So last lecture, we solved the problem dy by dx equal to minus 2x cubed plus 12x squared minus 20x plus 8.5. It's the same problem that we have now solved with Euler method, RK2 method, RK4 method. And then we did a comparison of how the different methods are accurate. And we just found out that RK4 gets you almost near perfect accuracy for this problem with a very crude step length of 0.5. And if you go to Canvas, I posted this Excel file. If you download it, you will have sheets up to RK4, which we did yesterday. So if you have this template or this spreadsheet, you can try to do more problems, which is what we are going to do. So I'm going to switch to my PowerPoint slide where I'm going to write like on the whiteboard. And we are going to solve one problem that is also in the homework. You can use this Excel sheet on the side to do your calculations or use your calculator as usual, whatever you prefer. But I'm going to use this Excel sheet, or in other words, I'm going to modify this Excel sheet so that I can solve a new problem with this sheet. And that's what you want to get used to, which is how do I use this template or this program to solve many problems and not just one particular problem. Okay. So before I start, any questions? Okay, so I'm going to share my screen. Give me a second here. All right. So you guys can see my screen, which has homework 5, problem 25.1. dy by dt equals yt squared minus 1.1 times y with an initial condition y of 0 equal to 1. And what we want to do is compute the value of y for t equals 0 to 2 with a step length of 0.2. Okay. So that is the problem statement. And first step, what you want to do is to, if this is an exam or if you're practicing, always write out the algorithm. Okay. So RK4 method, it's just copying the formula from the book or from your notes. Y of t plus delta t equal to y of t plus delta t multiplied by j equals 1 to 4 aj kj. So those who are here who are using their notebook to write this down, if you need time, you have to actually unmute yourself and speak, or you want to just turn on your video and make some gestures so that I'll understand if people need time. Okay. So feel free to interrupt me. Actually, it'll help if some of you at least can switch on your camera, and that'll give me some kind of live feedback that people are there. Otherwise, it becomes like a radio show. Thank you, Kyle. Yeah. All right. So here is our method. We have to write what are AJ values. You know that A1 equal to A4 equal to 1 over 6. A2 equal to A3 equal to 2 over 6. These are just values that I'm just writing from memory, but you can also see them in the textbook. If you go to page just 1 second here. Yeah. Page 735, section 25.3.3. Page 735, section 25.3.3. Okay, that is what you want to refer to both now as well as in the future during the exam. Okay. So we have our equation, and K1 is the function evaluated at Ti and Yi, and then K2 is the function evaluated at Ti plus
Professor,
half delta
question.
T. Yeah,
What's the equation that we're using for this one? Is it the same as the last ones?
yeah. I mean, you mean the ODE?
Like the function that we start with.
Yeah, that is going to be yt squared minus 1.1y.
Okay,
So
thank
this
you.
is the problem we are trying to solve now. Okay, this is homework. One of the problems in the homework. Is that clear?
Yeah.
Yeah.
Yes,
Okay.
it's clear.
So unlike the example we did in class, which involved only the x in the right hand side, now we have a function which involves x, that is time, the independent variable, and y, the dependent variable. So this will be a little bit different from what we did during the example in class. All right. So we have, I just want to write out the method because people need that practice of writing out the formula and seeing how the formulas actually constructed and come together. K3 is f of ti plus half delta t, and yi plus half k2 delta t. K4 is f of ti plus delta t, yi plus k3 delta t. So take half a minute here, write this down crystal clear before we go on to actually, calculating numbers. Okay. So the next step is for us to recognize or make a table of time. So we'll start with I, time, y of t. When I is 1, time is 0, y of t is 1. This is nothing but your initial condition. Just stating the first step. And then I is 2, time is 0.5, 3, 1.0, 4, 1.5, 2.0. And we want to fill out these values using our calculation. That is our end goal. Okay. So once you made this table, what you want to do is start with the first step. I equals 1, t equal to 0, y of 0 equal to 1. So you want to compute I plus 1. So that is y2 equal to y1 plus delta t multiplied by aj kj, j equals 1 to 4. I'll write it out like this only for like the first iteration. And then by the time we will be able to use the Excel sheet. So just for some time, it will be a little detailed. So y1 is known. This is nothing but y at t equal to 0, which is 1. Okay. Now we want to compute the k values. Need to compute kj values. Okay. So at any point, if I'm moving fast before you could write this down, please feel free to stop me, okay? Otherwise, I wouldn't know.
Professor, can you go back to the last slide for me?
Yeah. This one?
Yes, thank you.
Yeah.
Okay, I'm good.
You're good?
Yes.
Okay. So now, computing K1, K2, K3, K4. K1 is the value of the function at T1 and Y1. What is the function? Recall the function at t comma of the function of t comma y is, you need to just go back a few slides, yt squared minus 1.1 times y. So k1 would be, what is y? Y of 0 is 1. T of 0 is, time at 0 is 0 squared minus 1.1 times y. That makes k1 equal to minus 1.1. When you are unsure, or when you are not fully confident about how well you understand the formula, not understand, basically, if you're not yet familiar, I strongly suggest writing out every tiny step. That way you don't miss anything. Okay. Don't feel shy about it. Don't feel proud. Yesterday, on Tuesday, some of the problems I had was because I was trying to skip a few steps because I had a lot of content to cover. I just thought I'll take a step back and go slow. Okay, that's what I'm going to do today. So are we good up to here? K1 equals minus 1.1. Okay, so assuming that's a yes, moving on. K2 is the value of the function t1 plus delta t divided by 2, and the value of y1 plus half k1 delta t. So t1 is 0. That means t1 plus delta t divided by 2 is 0 plus 0.5 divided by 2, or 0.25. And y1 plus 1 half k1 delta t. What is y1? That is 1 minus half times 1.1, or I should write plus half times minus 1.1 times 0.5. What is this value? So as I am also writing here, I'm going to punch this into my Excel sheet so that we'll have.
Got 0.725.
Say it again, please.
0.725. That's what I got for that.
0.725. Others, please confirm that for me. So I'm also typing it into my Excel sheet. Plus, okay, maybe that's not too much. I can't do both. So let's just focus on the Excel, on the PowerPoint. All right, 0.725. Others, are you getting this? Okay, I'm going to go with Stephen's value. So K2 is the value of the function evaluated at t equals 0.25, and y equals what? 0.725. So that is y 0.725 times 0.25 squared minus 1.1 times 0.725. We'll again, once we finish this hand calculation, we'll go back and put this into Excel and cross-check everything, okay? Ooh, 24 participants. I like it. 2/3 of the class is here. It's good. Thank you all for coming.
Professor? Yesterday in class, there was a problem where we had to solve for L1, L2, L3, and L4. What's the difference between this problem and that one?
Problem and that. So that was a second order differential equation. To start off, we are just doing a first order differential equation, which is one of the problems asked in the homework. As the second example, we'll do a second order ODE. So that in class on Tuesday, I felt that I rushed things a little more than I should have. So I'm taking a step back and doing this a little slower, trying this a little slower.
Okay.
All right. K2, anyone has computed?
I got negative 0.752.
Negative 0.752.
That's what I got.
That's what you got. Thank you, Hunter. Okay. So K1, recall that K1 was minus 1.1 and K2 is actually, I'm going to go here, insert another slide and start writing down these values. K1 was minus 1.1, K2 was 0.725, K3, K4. Okay, I'll come back to that slide. All right, shall we move on to K3 now? So then K3, always start with the formula f of t1 plus delta t divided by 2, y1 plus half k2 delta t. That is the formula. Again, t1 plus delta t divided by 2, we just did that calculation, that is 0.25. And y1 plus half k2 delta t. What is y1? y1 is 1 plus half. What is k2? We just did that calculation. Was it, it's minus 0.752, right? I had it. Kyle, it was minus 0.752, right?
Yes.
Minus 0.752. Thank you. So that is minus 0.752 multiplied by delta t being 0.5. So now this number, if you compute and tell me, that will be y1, that is the y value.
I got 0.812.
0.812. 0.812. Is anyone able to confirm that?
Yeah, I got that
I also
too.
got that.
Okay, so those are the t and y values. So now if you go on to actually computing K3, which is the function evaluated at t equals 0.25 and y equals 0.812, that will be, what's the function? The function, recall, is y t squared minus 1.1 times y, that is 0.812 multiplied by 0.25 squared minus 1.1 times 0.812. So you need to compute that, which I am also attempting, which with my Excel sheet. 0.812 minus 0.8425. Are we getting that? Yes, Hunter? Okay, thank you.
Yes.
That's what I got.
To be honest with y'all, this is easier than writing on the whiteboard. It doesn't have any, like, I don't have to spend time wiping the board. So maybe I should bring the iPad and project it on the screen. Anyway, that's K3. Let's go back and put it down, minus 0.8425. And then K4. Let's go for K4. Remember, K4 is the function evaluated at t1 plus delta t and y1 plus k3 times delta t. T1 plus delta t is easy. That is 0 plus 0.5 equal to 0.5. Y1 plus k3 delta t. What is y1? That is 1 plus k3 is minus 0.8425 multiplied by 0.5. So this must be 0.5788. Are you getting that? Point 5788. Yes?
Yes, sir.
Got
Okay.
it.
Yes.
All right. So now that the last step is to actually compute K3 as the function evaluated at t equals 0.5 and y equals 0.5788, which is yt squared minus 1.1 times y, 0.5788 multiplied by 0.5 squared minus 1.1 times 0.5788. That is 0.5788 multiplied by 0.5 squared minus 1.1 times 0.5788 minus 0.4920. Minus 0.4920. Well, this is K4. I'll come back here. I'll just put this down in my list. Minus 0.4920. So let's take half a minute here and you tell me if you are all caught up to here.
Could you go back a slide so I can read the math that you did?
This one or this
Thank you. Yeah, that one. Thank you. I got it.
Got it? Okay. Others, can we move on? Perez, you're doing okay? Darian, Blake, April, all doing good? Yes? Okay, thanks.
Yes, I'm fine.
Yeah, there's a like a thumbs up or a tick sign that you can use to tell me that you're doing fine so that I can just, move on. Okay, so we have K1, K2, K3, K4. We also previously had the A1 values, remember? A1, let me just move this over here. So I have my RK4 method. Now I have my A values and K values computed. So now I can go out here, add another slide and compute Y at 0.5 seconds, which is Y at 0 plus summation J equals 1 to 4 AJ KJ, which is 1 plus, I'm going to write this, AJ is what? 1 over 6 multiplied by minus 1.1 plus 2 over 6 multiplied by minus 0.752 plus 2 over 6 multiplied by minus 0.8425 plus 1 over 6 multiplied by minus 0.4920. I know you can get the next step easily, but I want you to write this down the way I've written it so that you see where each number actually comes and fits in.
Professor, can you go back to where we have the K values listed for a second? Okay, I got it.
Okay. So let me also do the calculation while you guys do that. and we'll compare our numbers. 1/6 times 1.1.
Professor, do you not have to multiply the summation by your step length?
Yeah, I keep missing that. Thank God I'm not taking the exam. Yeah, I had it here, but when I got down to do the calculation, I missed that. Thank you. So I have to multiply this entire parenthesis by 0.5, which is the time step. Thank you. So then 6016. I'm getting y of 0.5 is 0.6016. Y of 0 was, of course, 1. Is anyone getting this value?
Yeah, Hunter and I both got it.
Okay, 0.6016. Thank you. So now we remember at the start we made a table. Our first entry now is 0.60. Oops. 0.6016. Okay. Let's give half a minute for people to get this number and confirm it. Are we all able to get this?
Yes.
Okay, good. So this is I equal to 1, I equal to 2. So you can see that this involves several calculations. To be precise, it involves computing the function 4 times, each time with a slightly different value of t and y, or x and y, if you call your independent variable x. And once you have these numbers, you have to put them back into the formula. And unlike me, you should multiply by the step length to get the value of the function at the next point, which is in this case 0.5. You can do this. That is, you would be able to do this for t equals 1.0, time equals 1.5, time equals 2.0. You can do this for any problem or this problem and so on. So with our calculations that we have done now, let's go to Excel. And now you have a reference. So when you punch in the formulas, you know exactly what to expect. And then we'll try to get that correct. Okay, so that once you set up the Excel sheet, you can quickly populate the values for later times instead of doing a hand calculation every time. Does that make sense? So keep this with you. Now I'm going to switch to my Excel sheet and we are going to continue the setting up the Excel sheet. Okay. So here is the problem we did the other day. It has a different problem. It's f of xy is different. So I'm going to just start with that sheet and make modifications. So until I say the sheet is final, don't write anything or don't copy anything. If you're doing this also with me, just open your Excel sheet and start doing these modifications. Okay. So our step length is still 0.5. Okay. Step length, we'll call it delta t. Okay. And our independent variable is time. And I'm going to delete this exact solution because this problem has a different exact solution. So we don't want to confuse ourselves. Okay. All right. My function f of t comma y is y t squared minus 1.1 times y. This is given in the problem. I'm just writing it down. A1, A2, A3, A4 values are always the same for this method, so they don't have to change. And I'm going to delete all this to avoid confusion. All right. And then your y exact is also different, so don't worry about it now. So this is where we start. Okay. So take half a minute to get here. Just keep a blank table with time, the y value at different later times, and K1, K2, K3 values that we'll do as intermediate steps. If you have this, tell me, and then I'll do the next. Yes, no. Are we following? At least a
Yes.
few I'm hoping are trying.
Got it.
Yeah, ready? Okay. So go to your what is that? K1 calculation. What did you have there? So you have to first compute. So if you go to your K1 calculation, you had to compute the value of the function at t1 and y1. Okay, so this is I equal to 1. This, sorry, not that. This is I equal to 1, I equal to 2, and so on. Okay, so let me move this out of the way. I equal to 3, 4. I'll just put I. 1, 2, 3, 4, 5, 6. We are interested only up to here. So let's delete this. At the end of this, you should have all the information you need to turn in your homework the first problem in homework 5. Okay, that's what I'm aiming for. So K1, let me write some notes here. K1 is evaluated at T1 and Y1. That's easy. You just have to take this function. I evaluated at T1, which is T equal to 0, and Y1, which is 1, or cell K3 here. So I'm going to write Y multiplied by T1 squared minus 1.1 times Y.
Hey, Professor, why are you using that y value?
See, when you do this as your current, this becomes your next. That is, current is always what we call I, and sorry, current is what we always call I, and next is what we always refer to as I plus 1. So if you want to compute the next, you have to base it on the current. Okay. So this minus 1.1 agrees with what we computed by hand. Okay, so now let's go to K2. To compute K2, I'll write here, K2 is evaluated at T1 plus delta T divided by 2 and Y1 plus half times K1 times delta T. So I need to add two columns. I'm going to call them T1, T plus dt over 2 and Y, Y plus half K1 times dt. I'm adding two columns here. So these three, this is our focus now. Okay, we're now focusing on this. What is T plus dt over 2? What is T here? T is T1, which is 0, plus dt being 0.5. You have to lock it with the dollar sign, divide by 2. And then Y is the Y from the previous, from the current, plus half times whatever K1 is multiplied by dt, and then lock the dt. So that agrees because we computed 0.25 and 0.725 for these values of T and Y. And then you want to write Y times T squared minus 1.1 times Y. So I'm going to give you 5 minutes to actually get these three values done and make sure you understand.
Professor, can you click on the 0.25 cell?
0.725.
0.25.
Yeah. So you want to know how this is got?
No, just how you calculated 0.25.
Oh, 0.25. That is
Yeah.
that is basically the time, the current value of time plus half the step length. That is the formula.
Okay.
Can you click on 0.725? Thank you.
So let me color code these values so that it's easy to quickly identify them. Okay, so we have our K1, we have our K2, so far so good. To compute K3, we need to add two rows. Okay, let me write my note here. K3 is evaluated at T1 plus dt over 2, comma Y1 plus half K2 times dt. So I have to write T, actually to keep it consistent, I'll just drop these one subscripts. All right, so I need a different color. All right, so I have T plus dt divided by 2, and then I have Y plus half times K2 multiplied by dt. Okay. What is T plus dt by 2? It has to be 0.25 again. It's the same 0 plus 0.5 divided by 2, and then Y plus half K1 times dt. Sorry, Y plus half K2 times dt. Sorry. Half K2 times dt. So that is our Y is this y from the current step, which is 1 plus half multiplied by k2, whatever k2 is, multiplied by dt, and then you have to lock it. So let's see what we got for this. We are seeing some difference, aren't we? It's not, okay, that's.
I got the same number you did.
Oh yeah, 0.812, that's right. Yeah, we are not seeing the difference. I'll just round everything to 4 decimal points. Okay, yeah. All right. So K3 is evaluating the function, function being y multiplied by t squared, t squared minus 1.1 times y, 0.8424. Yep. Point 8424. Are we all keeping up? Yes. Yes. Thank you, Omar. Thank you. All right, good. So we are up to K3. Okay. So now we'll write another annotation. K4 is evaluated at t plus dt and y plus K3 times dt. That's the last of the K values. So I have to obviously include 2 more columns, t plus dt and y plus K3 times dt. And I want to give a new color for these 3 together. So t plus dt is easy. That's just the time in the current step plus the step length and then lock it. And then y value is y from the current step plus K3, whatever that is, times dt and then lock it. Point 5788. That agrees as well. Okay. So now I'll put these 2 values and compute my function, which is y times t squared minus 1.1, minus 1.1 times y. 0.4920.
Can you give me a minute to write this down?
Yes, yes, of course.
Can I see the K4?
I got it. I got it.
Yeah, yeah, yes, you can. Are we all caught up? Yes. Tristan, how are you doing? Good. Thank you. Sailor, haven't heard from you today.
Yes, I'm caught up.
Okay, good. Okay, so I'm now going back to my Excel sheet. And then now what I need to do? I need to compute the formula. Or I think I wrote it somewhere here, or maybe I haven't. Okay. So y at t plus delta t is evaluated as y of t plus summation, or instead of summation, I'll just write a1 k1 plus a2 k2 plus a3 k3 plus a4 k4. That's the formula really. So now we need to put that in this cell Q4. So that is the y in the current value. My nemesis dt. All right, y in the current value plus dt, which is 0.5. I'm going to lock it, multiplied by, I have to start a summation, a1. I need to lock a1 because it's not going to change, plus k1, I'm sorry, multiplied by k1 plus a2, lock it, multiplied by k2 plus a3, lock it, multiplied by k3 plus a4, lock it, multiplied by k4. I'm going to show you that formula. So let's give this a different color. All right. Oops. So type this in. Here's the formula. And that 6016 is what we got, I think. Yep, 6016. Okay. So now we have computed for I equals 2. We mean I equals 1 is the initial condition. Okay. 1 is nothing but initial condition. Okay. And then we computed for I equals 2. And now to do I equals 3, you don't have to do anything extra. Okay. You just have to copy these formulas to the next row and then subsequent rows. The pitfall here is where you can make a mistake is if you forget to use the $sign to lock your dt values or a1 values wherever they appear. If you forget to do that, when you copy them onto next cells, you will get some errors, or like you will get some junk values. Okay, that's one thing to watch out for.
Are we only going to 2 in this example?
Say it again.
Are we only going to t equals 2 in this example?
Yeah, that's what the homework problem asks. You can go for a few more seconds. And in fact, this problem here might have an analytic solution, because on the other side you have dy over dt equals f of t comma y. So you can separate out the y, take it to the other side, and actually let's get the exact solution so that you can cross-check these numbers. Okay. So kindly tell me if we are all up to here, and then we'll get the exact solution.
I tried copying it over, but I got a bunch of different numbers. I'm not sure what I did.
You forgot to lock the dt somewhere. That's the most probable cause. So if you see here, when you compute time or wherever dt appears, you have to put that $sign. If you forget that, it could be a problem. Are there others who were able to get these values? Maybe I could have also made a mistake. That's why I'm going to compute the exact solution and cross check.
I got those values too.
I
You
did
got,
not.
all right, someone else also said, thanks. And we'll see now in a second that if we get the exact solution, how this can be cross-checked. And the last column here is basically the absolute error expressed as a percentage, which we will compute once we get the exact solution. Okay. All right, so just a quick break from Excel. We are going back to PowerPoint where we'll derive the exact solution. Okay, and I'll show this screen back again. Okay, need to get my screen share. All right, we're back. So what is our equation? Deriving the exact solution. Exact solution for check. dy by dt equals t, was it t squared y minus 1.1 y, which is y times t squared minus 1.1. Okay, which you can now integrate using whatever you learned in differential equations class. Dy over y equals t squared minus 1 times dt, and integrating both sides, ln of y
Can you go
is
back a slide?
1 second, t cube minus 3 minus t plus a constant. Yes. Yeah. So here's your solution, which has an arbitrary constant. You know this from your differential equations class. Arbitrary constant, which you can evaluate using the initial condition. Recall that y of 0 is 1, which implies when t is 0, y is 1, and logarithm of 1 is 0. So this implies c is 0. So that's easy. Constant happens to be 0, which means y of t is nothing but exponent of t cube over 3 minus t. That is the exact solution, which is not hard to punch in and generate values. So remember that you are asked to solve for the value of y at discrete points, y of 0.5, y of 1, y of 1.5, y of 2. But this is valid for any t. So you can keep changing the resolution of your calculation. You can still use the exact solution to cross-check. Okay. So are we good here? Can we switch back to the Excel sheet?
Yeah.
Yes, okay. So going back there. So my y-exact is exponent of, wait, did I miss any step here? Minus 1.1 y, 1.1, that's the problem. So that is 1.1 times t. So this is exponent of 1.1 times t. So I have to go here. I by mistake made one, like I forgot that 1.1 factor. So if I put that in, my problem should get better. All right. So if you look at the exact solution and the absolute error, we are getting something that is about less than 1% overall. Okay. Less than 1% with a time step that is 0.5. Okay. Now, a couple of things. When we did the example with the polynomial and we used the crude step length, we were getting very small errors. But the polynomial was only depending on x, the independent variable. It didn't depend on y. So in that sense, it is a kind of a linear differential equation. If you take this example here, our function or the slope depends on both the independent variable t and the dependent variable y, making this what they call as nonlinear ODE, nonlinear differential equation. So our error here isn't as small as we got the previous time. It's about 1%, which is still good, not that bad for the time step we chose. But the important thing is doing the calculation for multiple time steps, methodically getting the K1, K2, K3, K4 values, using them together, not forgetting dt, and then getting the value of the dependent variable at successive times. This is the sequence you need to follow. Okay. Now, question for you. How will you adapt this sheet to solve another ODE problem different from this one? What about the another problem will be different from this problem? There are some aspects that will remain same, some will change. Which are the ones which will change?
Wouldn't you have to change your K1 and K2 constant, like those equations for your Ks?
That is, you have to change the way you evaluate K1, K2, K3, K4, or in other words, you have to punch in the appropriate function which appears here. The whatever is in cell, the cell C11 here, that is the one that is going to change from problem to problem. That's one of the things that will change. The other is the initial condition. So you will have to update the function. Okay. The initial condition also needs to be updated, specific for each problem. So these are the two things you need to keep in mind when you try to apply this sheet to solve another problem as you practice more. Okay. So I've left these notes here so that they'll be helpful for you when you try.
So our initial condition and our dy over dt need to be updated for each problem?
Yeah, every problem is different. See, the template is always dy by dt equals a function of t and y. That template will always be same. Each problem will have a different function and a different initial condition, meaning when you specify y at some known time, okay, there is y at some known time, that will keep changing. That you have to adapt. Okay. And let's do that. That is, we are going to take another problem just keep this sheet, but just modify and get you the solution for another problem without having to go through the work all over again. So for those who are trying, you have your own sheet. For those who, for some reason, couldn't try or couldn't keep up, what we are going to do is I'm going to post this Excel sheet onto Canvas. You can download it and try with me the next problem at least, okay? So let me just close this file, post it, and then come back.
Can you go back to your y-exact equation?
Yep.
And how you drive that?
Yeah, okay, so it's now posted on Canvas. So please re-download that file. And I'll go back to my PowerPoint slide. This one.
Yeah. That minus 1.1 times t.
Yep. Yeah, I when I did my derivation the first time, I missed that. So let me make it clearer. Okay, can we move on? Because we have about 25 minutes, and let's try to see if we can get one more example. Okay, problem 25.2. Okay, problem 25.2. Let me write it out. Oops. Problem 25.2. dy by dt equal to 1 plus 4t multiplied by square root of y with an initial condition, again y of 0 equal to 1, and we want to solve in the interval t equal to 0 to 1 in step length of 0.25. Write that down, but I'm going to take the Excel sheet. Again, I posted this, so please download and open the file. And we are going to do this on Excel fully. So tell me when you're ready. Kyle, can we move on? Yes, okay. Joseph?
Hey, Professor, do you mind if I see your percent difference?
Yeah. Wait, why am I getting so much echo? All right. Here's the percentage differences. So I computed that as 1 minus the solution, RK4 solution divided by the exact solution. And then I want to express that as a percentage. Okay, can we move on? Because we are, getting near the end of the class. So first step, I'm going to copy my RK4 problem 25.1 and create a copy, and I'll call it 25.2. That's the first step. And then my dy by dt equals f of t comma y. That won't change, but what will change is the next line. My function is now what? It is 1 plus 4t multiplied by square root of 0.5. It's not an Excel formula, it's just like text basically. So just typing it in here so that we'll have some reference. The initial condition also needs to be updated, but it just so happens the initial condition is also 1. Y of 0 is still 1. So we are kind of okay. Okay, y of 0 is 1. All right. And then the other thing different about this problem is the step length. The step length is given as 0.25, not 0.5. So I'm just going to update the step length. And the way I set up my spreadsheet, everything related to the time is just recomputed based on 0.25, and I get this. All right. Are you with me so far? Or I'll give you a second to catch up. Okay. Here's a true or false question. These cells where we compute t plus dt over 2, y plus half k1 dt, all these cells need not be changed. True or false?
True.
True. Who else is saying true? Hunter, okay. The cells like H, I, K, L, N, O, where we compute time and y coordinate, they don't have to be updated, okay? Because they just are definitions of where you are computing the function, not what you are computing. K1, K2, they have to be updated because they are actually executions of the function, which has now changed because we have changed to a different problem. So you can delete these K1 values, K2, K3 values, K4 values, and then we'll have to recalculate them or repopulate them by writing 1 plus 4 times t as in current time, multiplied by square root of y value and then K2 has to be evaluated at these 2 points, okay? So that is 1 plus 4 times t multiplied by square root of y. And then K3 is again 1 plus 4 times time, but now that time is cell K4 multiplied by square root of y, which is cell L4. And then K4, 1 plus 4 times t multiplied by square root of y, which is now cell O4. Oops, sorry, I made some mistake here. So punch in these values and tell me if you are getting these as well. If you're using the Excel sheet I uploaded, you should, unless I made some mistake. Omar, are you getting these? Yes. Curtis?
I'm not yet.
Not yet. Okay, that's fine. This first line is always the most crucial step. If you get it right and you didn't make any typographical mistakes in the Excel syntax, the rest should work itself out. Are we all getting this? Can we move on?
I'm getting it now.
Okay, thank you.
Yes.
Thank you, Tristan. All right, next step is pretty simple. Just drag this row, copy it onto the subsequent cells. Okay, here is one more true or false question. The last column where you compute the y value that is at the next time step based on your RK4 formula, will that change or will that need to be updated for each problem?
Theoretically, no.
No.
No, because it's just based on dt, which you have already automated by locking in the value of cell F1, and then A1, K1, A2, K2, A3, K3, A4, K4. If you update K1, K2, K3, K4 properly, A1s don't change. Everything else will just be computed naturally. So all you have to update is 5 places, one at the initial condition, actually 6 places. Step length, initial condition, and then the 4K values, and that's it. You can pretty much use this spreadsheet for any first order ODE problem. Okay. So now it's time to check the value we are getting. First of all, you guys make sure that you are also getting this and let me know if you don't. I'm going to type in the exact solution which I did by integration while you guys were working. Let me see if I'm correct. Not sure I'm correct. Let's see. No, I don't think I'm correct. Let's see here. Y t plus 2t squared plus c. Then y of 0 is 1. So that's 2. Oh. And then I have to divide by 4. I didn't go through the motions about calculating the analytic solution with you guys. I just did it myself. And I'll tell you what the solution is. Okay. So the analytic solution that I'm getting is y. Oops, sorry. Y. I might just as well type it. Exact solution. Y of p equal to 1 by 4 times 2 times t squared plus t plus 2 the whole square. That's the exact solution. So if I put this formula up here, my error percentages are pretty respectable, 0.01%. Okay. Now, questions. Is everything clear so far in this example? I mean, I got the
Yes.
analytic solution. Yes. Okay. Thank you, Stephen. I got the analytic solution. If you spend 2 minutes, you'll be able to derive it. So I'm not deriving it. If I put it next to my numerical solution and then compare the error, it's pretty good. So I think we did our calculations correctly. Okay. Okay. So There is one more problem in the homework, 25.19, and in the 10 minutes I do have, let me just give some hints about how to solve it, okay? So let's read the problem together. Here is problem 25.19. So it's a word problem. Assuming that drag is proportional to the square of velocity, we can model the velocity of a falling object like a parachutist with the following equation, where v is velocity in meter per second, and other quantities like t is time in seconds, g is given, it's a constant 9.81 meter per second squared. Coefficient of drag is given with unit kg per meter. Mass is kg, so we are asking to solve for the velocity and distance fallen as described by this equation by a 90 kilogram object with a drag coefficient of 0.225 kg per meters. If the initial height is 1 kilometer, determine when it hits the ground. So you just have to compute your numerical solution and see when your height or your, say, z coordinate becomes 0, okay? So what I'm going to do is just set up the problem and try to write it out as a second order ODE that you can solve, or a systems of differential equation that you can set up. And then you will apply Euler method, fourth order method, using the spreadsheets that we have created, okay? So let me go back to my PowerPoint. All right. So problem 25.19, dv over dt is mg, or not mg, it's g minus cd divided by m multiplied by v squared. Now g, cd, m are all given, so you don't have to worry about them. And then you can write, suppose this is the ground, okay? You have the parachutist jumping from a height h, okay? And we'll call this z coordinate. Let's say this is z equal to 0, this is z equal to h, or you can do it the other way. You can say, if it's easier for you to think in terms of an initial condition, this is z and z equal to 0, and this is z equal to h. Okay. Now what is speed? The speed along the z direction is nothing but the rate of change of position. So that is v. So these two equations need to be solved simultaneously. Okay. So I have dz over dt equal to v, and dv over dt equals g minus cd over m times v. Z at time 0 is 0, and v at time 0 equal to 0. Because we'll assume that the object was just dropped without giving it any initial speed. It's just let go, okay? So these are our initial conditions. This is the system of equations to solve, and we need to compute z and v until z is approximately equal to h, or z is slightly greater than h. And what is h? H is 90 kilo. Sorry, h is 1 kilometer.
Professor, isn't it v squared for dv dt? It's g minus cd divided by, yeah, thank you.
V squared, V squared. Sorry. So the height h is given as 1 kilometer. I mean, the numbers are there, but the main idea is this problem does not ask you to compute the solution for 5 seconds or 40 seconds. It tells you to keep computing and determine the time taken for the object to hit the ground. So that is the goal. Okay. So you can use the Excel sheet, do this problem, and we'll have a recitation session hopefully soon where I can do more examples on second order ODEs. Okay, so what I'm going to do from next lecture, we are going to start with statistics. Okay, for a moment, I'm going to stop my screen share and talk to you guys. All right. So for doing this homework, I think we have given you all the clues and information needed. That is, we now know how to solve first order differential equations using Euler method, RK2 method, RK3 method, RK4 method. We know how to solve systems of differential equations, which is a laborious thing to do, but it's not more complicated. It's just the same set of ideas. So we can solve the problems where you are given an equation for acceleration and asked to compute how the speed changes with time and how the position changes with time. You can set up both. By doing transformations, you can also reduce any higher order differential equation to, say, a second order differential equation can be reduced to 2 first order equations. A third order differential equation can be reduced to 3 first order equations, and so on. So you are in principle ready to solve all this. For the homework, you're being questioned on first order ODEs as well as systems of ODEs if you see it that way, or second order ODEs if you see it that way, either or. For the exam, you will be questioned only on first order ODE using RK4 method. In the exam, I will not give you a second order ODE or a system with three variables and ask you to solve those. That in the exam hall is sort of a big ask. So we'll stick to problems like problem 25.1 or problems like that for the exam. Of course, it will still be a word problem, but it will involve only first derivative. That's my point. Okay. As far as this unit goes, there is a lot more work we can do related to programming. Like you can use MATLAB to set up a code for RK4. And one thing that I am considering is, I know we have a conventional exam 3 and then a final that is be comprehensive. But if there are anyone amongst you who would like to explore this a bit further, come talk to me. If not for credit, at least I'll help you do some programming so that you can improve your skill. Okay, because as I always say, programming is a very vital skill for engineers to have. And this course offers a lot of opportunities for you to try simple things and learn a lot. Someday you might have to do very big things. At that time, you might not have the time to learn. So now is the time. Okay. So from Tuesday, we'll do statistics. The exam 3 will be on the last lecture day. And then by that time, just after the exam is over, we'll try to update your scores as soon as possible within a day so that you will be able to make a decision about whether or not you need to take the comprehensive final, which will be centrally scheduled during finals week. So if you already have good scores on your 3 exams, exam 1, 2, 3, you don't have to. If you want to improve your score and you take the final, you get a better score out of 60, that will be used to replace exam 1, 2, 3 scores as a whole. You can't replace exam 1 score and leave 2 and 3 same like that. That's not possible. Either you take exam 1, 2, 3 scores or the comprehensive final scores for your course grade. Okay, that's something to keep in mind. Again, we'll try to give you the scores as soon as possible after exam 3 so that you can make an informed decision about whether or not you need. Suppose you take the comprehensive final and unfortunately, if you do badly than your existing score, I won't hold it against you. I'll let you take whichever is the higher score so that your grade will be better. Okay. If you have any questions related to these, please feel free to contact me. We will try to return your exam 2 graded right after Thanksgiving. That's the plan. That's the plan towards which we are working. Okay. Any questions?
Will you be posting the what will be on the final exam online, or are you going to be giving that in class?
Yeah, I can post I can post a document describing how that exam will be structured, or I can, if I find a few minutes before exam 3, I'll try to talk about it. So remind me during the lecture before exam 3. That is the last but one lecture. Okay, yeah. But for those who have good scores, like anything that is 55 out of 60 in exam 1, 2, 3 combined, I wouldn't recommend that you have to take the final, because the final will be comprehensive. You have to learn everything from day 1 to the last lecture. So it really is it's a game of strategy. What is best for you to get a good grade? That's what you should think about. Okay. All right, we are 2 minutes over. Sorry about that. And thanks for attending our Zoom today. We'll meet in the classroom on Tuesday. Thank you. Bye.
Thank you.
Thank you.
Have a good day.
Thank you.
Thank you, Professor.
Thank you.
Professor, would you go back to your notes for a second?
You mean the PowerPoint slide?
Yes.
Yeah, let me stop the recording.